Today we're going to look at section 6 of chapter 10. Two objectives: to find the measures of central angles and arcs, and then to find their circumference and arc length. I'm going to start out with some basic information. Again, some of this is going to be review for you on that first page of your notes. First of all, on that left side, we've got circle. If you open that up, there's a place for you to write the definition of a circle. A circle is the set of all points equidistant, so the same distance from a given point, which is called the center. So that's our definition of a circle. So when we name a circle, you're going to see a dot, which kind of represents that center point. You're going to see a small circle around it. And then they are going to use the letter of that center point. So when we look at this example that you have there in the center of this notes page, this would be circle J. So a circle is named using its center point. So we use the symbol showing that center point along with a circle around it, and then that capital letter J. On the right-hand side in your notes, next to the circle, we have the diameter, something that we've talked about many times, not only in this class, but I'm sure at previous levels of math courses. The diameter is a segment. Okay. So that's important because we know how to name segments. It's a segment that contains the center of a circle and has both endpoints on the circle. So although there are many diameters that could be drawn in a circle, in our example, we just have one that has been drawn in. So to name that diameter, we're naming a segment. We know to name a segment, we use the two endpoints. So the two endpoints that we have are the letters G and D. We have the segment bar across the top. Okay. We could switch the two letters around. Order does not matter. Okay. So we could also name it segment DG if we wanted to. Okay. Order does not matter. So that's our diameter. Next thing we're looking at is radius. Radius is right below the diameter in your notes. Again, radius is something we are already familiar with. It is a segment that has one endpoint at the center and the other endpoint on the circle. So again, we're naming a segment. So when I'm looking for a radius in that picture, okay, there are several different radiuses that we could name that we see there. What would be one example of a radius in that diagram? Okay, segment JF, or we could switch the letters around, FJ. What are some other radiuses? JD. Okay, JD. JG. And JG. Okay. So those two parts of that diameter, because half of the diameter is a radius. So again, lots more that could be drawn in the diagram. Those are the three that we see already drawn in that picture. Then moving to the next page in your notes, got some other things that we're going to talk about. First one is the central angle, upper left-hand corner. So again, we want to look at a definition and then how to name it. A central angle is an angle whose vertex is at the center of the circle. So there are many angles that we see drawn in that circle. As long as that vertex is at the center of the circle, that's what we call a central angle, because the vertex is at the center. So these central angles then have special names depending upon their size. Okay? So when we have a central angle, that angle is going to intersect part of the circle. So a semicircle is going to be half of the circle. So when I look at my diagram, I have my diameter, ED, that is cutting that circle into two halves. So two semicircles. So one of my semicircles can start up here at E and go around the left side. And the other one goes around the right side. So when we name a semicircle, we are going to be using 3 points to name it. We are going to use the two end points, and then we also need to have one other point that arc goes through, so we know which half we're talking about. So if we're looking at that green semicircle, okay, we have E, then it goes through point A, and then gets to D. And instead of having a segment bar, we're going to have an arc that goes across the top of those.
What was the name for the central angle?
Okay. Central angle, we would just name an angle just like we normally do.
Okay.
And we'll talk about that here in a little bit.
Like angles.
Okay, so we can't just say angle C because there's all kinds of angle C's. Okay. So if we were looking at the central angle that's associated with this semicircle, okay, with the semicircle we don't actually have a central angle because the angle would be, for example, ECD, okay, but that's not an angle. An angle can't be 180 degrees. Okay, it has to be less than that. Okay. But when we talk about the minor and major arcs, then we'll also talk about those central angles. Okay. So again, the order doesn't matter as far as the two end points. Okay. We could say we're starting at D, we're going through A, and then we get to E. So if you just think about tracing around that semicircle, we need to name one point that's on the circle, or semicircle, other than the two end points. So when I do the yellow one, okay, again, if I start with E, this time I have several options on my diagram. I could use the point B, or I could use the point F. You can choose which one you want to use. Do not use both of them. Okay? And then we end at D with that arc across the top. So again, we could start with D, end with E, that doesn't matter. But we have to have that point in between so we know which of the semicircles we are referencing. Then we have major and minor arcs. So when we look at a minor arc, a minor arc is smaller than a semicircle. Okay, so it's going to be less than half of the circle. When we name a minor arc, we are only going to use 2 letters, the 2 endpoints. So there are lots of examples of minor arcs in our diagram. What would be one example?
EC or EBF.
Okay, so again, we're only using 2 letters when we name a minor arc. Okay, so what are we going to use? EF. Okay, so EF with the arc. So when we talk about minor arc EF, we're talking about this blue part. Okay, it's less than half of the circle. What would be another example of a minor arc? Lots of them in the picture.
FD.
Okay, FD would be another example of a minor arc. Okay? So when we look at those minor arcs are formed by these central angles. So if I'm looking at arc FD, the red arc, the angle that made that arc, or kind of cut that arc, is the red angle, which we would name angle FCD or angle DCF. So when that angle is drawn in, the part of the circle between or inside that angle is where that arc is being formed. Okay, so a central angle, and then we can see its minor arc. Same thing can happen with a major arc. Okay. We just, again, can't really look at that angle measure because angles can't be greater than 180. Okay. A major arc is larger than a semicircle, so it's going to be more than 180 degrees. Okay, so we can't name a central angle. Central angle only goes with that minor arc. A major arc, because it's larger than the semicircle, we need to use 3 letters. So just like a semicircle, we're going to use 3 letters. Because if I think of my minor arc EF, which was our blue, we can also have a major arc that uses those 2 endpoints, E and F, but it has to go the other way around the circle because it's going to be larger than the semicircle. Okay. So to go with EF and be the major arc, it's going the other direction. It still starts and ends at EF, but we need to have a letter that's on that arc also. So we have several options. We could use the letter A or the letter D, whichever one you want to use. So when we name a semicircle or a major arc, we have to use 3 letters. A minor arc is only using 2 letters. So we're going to talk now about an arc measure. Okay, this isn't in your notes as far as a place to write it. We're going to be using it to fill in that centerpiece. Okay? So this concept tells us that the measure of a minor arc is equal to the measure of its corresponding central angle. The measure of a major arc is the measure of the related minor arc subtracted from 360, because a full circle is 360 degrees. If a full circle is 360, then a semicircle is going to have a measure of 180. Okay? So what this is telling us is when we see this example here, this angle S is 50 degrees. The measure of its minor arc is also 50 degrees. Okay. So what would be the measure of the blue major arc? 310. Okay, we take 360 minus the 50. So the blue major arc is 310. So in that second page of your notes, if you open that all up, in the center, you see this diagram. And then we want to find the measure of each arc or angle named, because sometimes we have angles, sometimes we have arcs. Okay, so we're going to fill that in, and then next to each measure, you're going to write the name of the arc or angle. So it's opposite piece, and they're telling us that ED is a diameter. Okay, so we know it's going straight through that center point. Okay. So we've got a couple pieces to help us. We know that DF is 60. We know that arc AE is 45. So we're going to use that information to help us. So the first thing they're wanting is the measure of angle FCD. So angle FCD, what is going to be the measure of that angle? It's going to be 60 because arc FD is 60. Okay. Now we want the measure of arc AE. What's the measure of arc AE? 45. That was given to us. Okay. What is the name of the central angle that is congruent to that? Okay, angle ACE. Next one. Okay. When I look at this, I know I've got a major arc. If I follow that or trace it around, I'm starting at A, going through D, and ending at F. So how can I find the measure of that major arc? I've got a piece of it here that's 60. How can I find the other piece from A to D? How can I find arc AD?
Could you take 180 and subtract 60?
I can't subtract 60 because this is not a diameter. My diameter is going from E to D, so how does that help me?
And those two.
If
You subtract-
ED,
Don't you subtract 45 from 180?
right, I'm going to subtract 45 from 180. So AD is going to be 135. So if AD is 135, DF is 60, I add them together to get 195. Okay? Because it's a major arc, I cannot name a central angle that goes with it. Okay, you can only write central angles for minor arcs. Next one, I need the measure of arc AD. Okay, that's the one that we just found to help us find the previous. So we know that that's 135. What would be the name of the angle, central angle that formed that arc? Angle ACD, or you could name it angle DCA. Next one, we want the measure of angle ACD. Okay. Angle ACD formed the previous arc AD, so it has to also be that 135. So we're seeing that connection between the two. Next one is angle ACF. What would be the measure of angle ACF? Angle ACF. We know ACE is 45. How can I find angle ECF?
So subtract 60 from 185.
Subtract 60 from 180, which leaves us with 130. Then we add the 45 to get 175. What's the arc associated with angle ACF? What arc goes with that angle? What arc, what part of the circle is being cut with that angle ACF? Okay. We're just going to use 2 letters because it's a minor arc. So AF. Next one is a major arc, arc AFD. So it's starting at A, it's going clockwise because it goes through F before it gets around to D. So we've got 3 numbers that we can add together. Okay. We can do the 45 plus the 130 plus the 60. So 235. Another way that we could have found that major arc, okay, that previous piece we looked at said we could subtract the minor arc from 360. So the minor arc is AD, which is 135. So if I subtracted that from 360, and then this last one. Oh, nope, that should have been a 120. That wasn't coming out right. Right, yep, this should have been 120. So then this is going to be 225. Okay, so again, because it's a major arc, there's no angle to go with it. Last one is arc FDE. So FD all the way around. So again, 2 options. We can add the 45, the 135, and the 60. Or we could take the minor arc, the 120, and subtract from 360. Either way, we're going to get an answer of 240. And again, because it's a major arc, can't look at a central angle that connects with it. And then on the next page in your interactive notebook, you've got that circle piece that we filled in. In the upper left-hand part of that, you see those words circumference going around. So inside that circumference circle, you can write down again the formula for circumference of a circle. This too is not something new to you. We worked with it first semester. You've also worked with it in previous math classes. So for circumference, we can use pi times diameter, or we can use 2 pi times the radius, because 2 pi is equal to your diameter. So either one of those formulas can be used for circumference. Associated with circumference then is arc length. So this is where reading comes into play and having to pay close attention to detail. Because what we did on our previous notes page was working with the measure of an arc. The measure of the arc was the same as the degrees of the central angle. Now we're working with arc length. Arc length is the top piece on the 4th page in your interactive notebook. Okay? So arc length is different than the measure of an arc. Okay? So the arc length is a portion of the circumference of a circle. It's a portion of the circumference of a circle. Below that, okay, you've got empty space. You are going to want to write in this formula. Arc length then is the measure of the arc, which we just got done looking at. It's the measure of the arc divided by 360, which is a full circle, and then multiplied by your circumference, which is 2 pi r. So that's your formula. And then below, on your notes, you have arc length and measure of arc. You need to fill in the not equal to. Okay? So again, arc length and measure of the arc are not the same thing. Okay? The measure of the arc, we said, was the same as the central angle. So if I had a 90-degree central angle, okay, it doesn't matter how small my circle is. I'd have a 90-degree central arc, which is also the measure of that. Or I could have a great big circle with a 90-degree central angle. Okay? So the measure of the arc in my small circle and my big circle is 90. The length of the arc is talking about this part of the circumference. So how long the blue piece is. So even though my central angle and the measure of my arc are the same in these two circles, the arc length is completely different based on the circle size. Okay? So again, very important that you read words carefully. Need to know that the measure is different than arc length. So arc length, we're always going to use this formula. So we've got an example here. So to find arc length, we take the measure of the arc, which is the 70 degrees,
We divide it by 360. And then we multiply it by 2 pi r. So 2 pi times r, the radius, which is 4. So when I put this all together, my fraction piece I can simplify. I divide out a 10. 7 over 36 can't simplify any further. When I find my circumference, 2 times 4 is 8, so I have 8 pi, which as a fraction is over 1. Then I need to multiply those pieces together, or I could simplify first. What number goes into both 8 and 36? 4. So now when I multiply straight across, I'm going to get 7 pi over 9. And I am in centimeters.
Would it be 14 pi? Because that's times 2.
Oh, I'm sorry. Yes, it is. Thank you. $14. Okay, so 14 pi over 9, or you could say 14/9 pi centimeters. Okay. So when we're working with the length of the arc, we need to make sure we always label. When we're talking about the measure of the arc, that measure is degrees. Okay, so the measure of the arc is always degrees, where an arc length is going to have some measurement attached to it. In this example, it was centimeters. So that is the end of our notes for today. Okay. So we had some review pieces, lots of terminology just as far as parts of a circle. Probably most important thing from today's lesson is to make sure that you, again, understand this difference between the measure of the arc and the arc length. Okay, understanding the difference between those two is the biggest, most important takeaway from today's lesson.